Right. A venturi meter is used to measure the velocity of a flow of fluid. The area of larger cross-sectional area of the tube is 4 times greater than the smaller cross-section. Find the value of V. So they are asking the velocity here, right? So to do this question, we have to apply few equations and we have to be very careful regarding the data that is given here, right? So first equation I need the connection between these two velocities. So I'm going to apply a1 v1 equals a2 v2, equation of continuity here, our first equation. So here velocity, I'll take it as 4. If the cross sectional area is 4a here, that is larger one, so let's take the velocity here as v2, so that into a, so I get v2 equals 4v here, right? So we have velocity connection now. So to find the velocity, the value of the velocity, we need to apply another equation, that is, Bernoulli's equation, right? So P plus half rho V squared plus rho GH equals K. That's a Bernoulli's equation. We have to apply this equation now. So let's get into the question. Right, let's get into the question now. So here I'll put pressure here as P1 and P2. So what we have to do is we have to apply Bernoulli's equation. So applying Bernoulli's equation, I'll put to these P1 and P2 points. So pressure here P1 plus half rho V squared, that's the density of the liquid flow, plus rho GH equals P2 plus half rho V squared again plus rho GH. Right. So this rho GH and rho GH we can cancel it off because it's the same height. So again I can write it as P1 plus half rho V squared equals P2 plus here velocity. Now we have to know that. So the velocity here I can take it as v. If I take the velocity is here v, so the velocity here is 4v, right? So then again I'll put half rho 4v squared, right? So then what I have to do is to find v, so we need to take p1 minus p2 to that side and to the other side. So here we get half rho 16v squared. I'll simplify it, half rho v squared. So if you didn't do this question, now if you are watching it now, just let's do it together, then you'd understand it properly. Just rather than passively watching it, keep practicing it, just follow through with me. So half here, so I can see that half rho is common, so I get 16v squared minus again v squared here, so I get half rho 15v squared equals p1 minus p2. So to find v squared here, 2 p1 minus p2 divided by 15, I get v squared, right? So to find p1 and p2, again we have to work on it. Right, now we have this equation, right? So here to find P1 and P2, we have to use this. Now we know in a U-tube, equal level in water has the same pressure. So here pressure, let's say this is point C and point D. So I know PC equals PD, right? Using this, we can connect P1 here and P2 here. There are a couple of things we need to know. The height 20 millimeters, and up to here let's take the height as x. So here this height we can take it as 20 plus x. So 20 plus x, we have the liquid in the flow, in the flowing liquid, and here only up to x we have this liquid, flowing liquid. right? So let's write the equation. So Pc is, that is equal to P1 plus this 20 plus X into the density of this liquid, right? So density is 20, 2000, 2000. So that into 10 again, 20 plus X is from millimeter, so 10 to the power minus 3, right? We have that pressure now. And on the other side, D pressure. So that means we have to add P2 plus X value. So this X part, yes, we can write X, we can convert into meters 10 to the power minus 3, the liquid density 2000, and that into 10. And this 20 millimeter part, that plus, so we get 20 into 10 to the power minus 3 meters, and the density of this liquid is 14,000. That's mercury. So 14,000, right, that into 10, we get that value. So let's equal these two value, and from that we can find V P1 plus P1 minus P2, right? So I have done the calculations here. Let's go through the calculations again. Now you can see this is the equation we got. So let's simplify it furthermore. So P1 plus here, let's remove the bracket, 20 into 10 to the power minus 3, that into 2000 plus into 10 plus X, this value, and P2 on the other side, P2 plus X into this value, and finally this. So when we are equalizing these two, there are two things that are equal. Now you can see this value, and from P2 side this value, these two are equal, so we can cancel off these two. So then we can go to a equation here, right? So P1 plus 20 into 2000 into 10 to the power minus 3 into 10, and that is equal to P2 plus 14,000 into this value. Simplified furthermore, we'll be getting P1 minus P2 equals 2400. Now we have a value. Then let's apply to, right, now we have P1 minus P2 as 2400. Let's apply the values here. So 2 into 2400, that divided by 15, and rho is 2000, that is equal to V square. Let's simplify it furthermore. So here this 20 we can cancel it off for this, right? So here, and again 3, 8, 3, 5. So here we get 18 divided by 100, 16 divided by 100, so V square. So let's take the root value of this. So 16 root 4, and 10 here, 100 is here, 10, so it's 0.4 meters we get as V. So answer we are getting is 0.4 meters as the answer here.